In this lesson, we'll look at techniques for solving quadratic equations. Let's start with the definition of a quadratic equation. First, let A, B, and C represent real numbers. Where A is not equal to 0. A quadratic equation is an equation in the form ax squared plus bx plus c equals 0, where x is the variable. The a, b, and c are called the coefficients. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. Let's look at how to solve quadratic equations using the zero product property. First, that property says the following. If you have two numbers, m and n, and they multiply together to give you 0, then the only way that this can happen is if the first one, m, is equal to 0, or the second one is equal to 0. So if you have two numbers that multiply together to give you 0, then one of them has to be 0. This rule can also be extended for 3 numbers multiplied together, 4 numbers, etc. We'll use that to solve some problems coming up. In example 1, we have the solve for x squared minus 5x equals 6. So first I'm going to write that as a quadratic equation with the 0 on the right side by itself. So we'll move the 6 over. It comes over as a negative 6. And we have x squared minus 5x minus 6 equals 0. This one factors. It factors as x and x. And then 6 factors as 6 and 1. To get the signs right, we have minus 6 and plus 1. Now notice that this is in the form of two things multiplied together to equal 0. So this is where we use the zero product property. It tells me that when two things are multiplied together and equal 0, then either the first one is equal to 0 or the second one is equal to 0. Those are going to give us the two different solutions for x that would make the original equation true. Basically, we split it up here, set the first one equal to 0, set the second one equal to 0, and then solve each of those equations for x. So we have x is equal to 6, and x is equal to negative 1. So we have two solutions for this equation. And of course, we write this as a solution set. I'll write SS for solution set. And it's both of these, 6 and negative 1. Let's look at example 2. Solve for x. 4x squared minus 8x equals 0. This quadratic is already written in the standard form with the 0 on the right side by itself. So we're going to factor what we can. Notice that both terms on the left have a 4 as a factor. They both have x as a factor. So I'm going to factor out 4x. From the first term, that leaves me with x. And from the second term, that leaves me with minus 2. Here, we have 3 factors being multiplied together to give us 0. We have the 4, the x, and the x minus 2. We set each of these equal to 0. So 4 equals 0, x equals 0, and x minus 2 equals 0. The 4 equals 0 doesn't make any sense, so we get rid of that. X equals 0, that one's already done. and then solve the last equation with x equals 2. And we'll write this as a solution set. So the solution set is 0 and 2. Let's look at page 2 and the square root property. The square root property says that if you have an equation that is x squared equals k, then the x is equal to plus or minus the square root of k. And the x may not just be the variable, it's just generalizes to when something is squared equals a number, then whatever that something that was being squared is equal to plus or minus the square root of that number. Let's use the square root property to solve example 3. Solve for w. W squared equals 25. So that means that w is equal to plus or minus the square root of 25. And the square root of 25, of course, is 5. So the solution set is plus or minus 5. Example 4, solve for t. 2t squared is equal to negative 200. First we need to divide both sides by 2. Let me write the equation. Then divide both sides by 2. And we get t squared is equal to negative 100. Take the square root of both sides. So t is equal to plus or minus the square root of negative 100. We know that the negative under the square root comes out as an I and leaves the square root of 100, and the square root of 100 is 10. So we're left with plus or minus 10I. So the solution set is plus or minus 10I. In example 5, we have sort of a larger version of something squared equals a number, but the square root property still applies. We have quantity 3 squared minus 1. All of that squared equals 4. So let's take the square root of both sides. We get 3v minus 1 equals plus or minus the square root of 4, which is 2. And then we need to solve this for v. So I'll move the 1 to the other side. So we have 3v equals 1 plus or minus 2. And then I'm going to divide by 3. So v is equal to 1 plus or minus 2 over 3. To get the two individual numbers, I'll go ahead and split that up. And I'll use the plus one first, plus version here. So v is equal to 1 plus 2 over 3. We'll finish this one out. That's 3 over 3, and v is equal to 1. And then I also get v is equal to 1 minus 2 over 3, using the minus sign from the plus or minus. And so that's v is equal to negative 1/3. So together, the solution set is 1 and negative 1/3. Example 6. The volume of a right circular cylinder is V equals pi r squared h, where r is the radius and h is the height. Solve the volume formula for r in terms of v and h. When a problem says solve in terms of certain variables, that means it's okay to leave those variables in the answer. So let's start with the formula for volume. Volume equals pi r squared h. We're looking to solve for r, so I'm going to divide by the numbers that are being multiplied by r squared. So that would be the pi and the h. Of course, we divide that on both sides. So we now have v divided by pi h is equal to r squared. We'll use the square root property here. Take the square root of both sides, and we get r is equal to the square root of v over pi h. We don't use the plus or minus this time because we know that r has to be a positive number since it represents the radius of a cylinder. Let's move on to completing the square. In example 7, find the value of n that makes x squared plus 18x plus n a perfect square trinomial. Then factor the perfect square trinomial. So the process of completing the square starts with the first two parts of a quadratic, and it figures out what this last number should be in order to make a perfect square trinomial. A perfect square trinomial is one that factors into two factors that are exactly the same, i.e. it's a perfect square. So to do this in the process, you start with the coefficient of the x term, and that's 18, and we'll take half of that. Half of 18 is 9, and then take the 9 and square it, end up with 81. So n is equal to 81. 81 is the only number that will make x squared plus 18x plus some number a perfect square trinomial. 81 is that number. So let's write out the new trinomial. X squared plus 18x plus 81, and then factor that. It's supposed to factor as a perfect square, so we know it's going to be something squared. We always start with the variable, and then we pick up whatever sign was in the middle here. So this is going to be a plus. And then we pick up whatever number was half of the b. That comes over here. So the factorization is x plus 9 quantity squared. Now that is the procedure for completing the square when the lead coefficient is 1. The lead coefficient is the 1 in front of the x squared. In example 8, we look at an example where the lead coefficient is not 1. Example 8. Find the value of n that makes 3x squared minus 6x plus n a perfect square trinomial. Then factor the perfect square trinomial. So I'm going to start by writing out what we have so far. And I'm going to leave the n part off for now. To complete the square, when the lead coefficient is not 1, the first thing you must do is factor off the lead coefficient from the first term and the second term. We're going to figure out what goes in the blank as part of completing the square. Now that you've factored out the 3, you just complete the square on this inside part alone. So we take the 1/2 of the b term, and I'm just going to use 2. It's really a negative 2, but you can do the negative sign later. 1/2 of 2 is 1, and then you take that 1 and you square it, and you get a 1 again. So what goes in the middle here is 1. And so technically, let me write it here, that makes 3x squared minus 6x plus 3. So n is equal to 3 is what makes it a perfect square trinomial. To factor, I'm going to start with this version that already has the 3 factored out. If you start with the other version, you just have to factor out the 3 first, and that's okay. And then this is going to factor just as in the previous example. You pick up the variable, you pick up the sign from the b term, it's minus, and then you pick up what 1/2 of b was, and that's a 1. So it factors as 3 times 1 minus x squared. In example 9, we'll solve the quadratic by using the complete the square. The quadratic is x squared plus 9 equals 10x. Our first step is to move the 10x to the left, so it comes over as negative 10x, and then it's set equal to 0 on the right side. To complete the square, we need to rewrite this in another form. So we're going to have the first two parts in the first piece, so x squared minus 10x, and then plus blank, plus 9 on the outside, and then another blank. The goal of completing the square is to fill in those blanks with the appropriate number. We'll complete the square on this first piece that we have written in parentheses. We'll take half of 10, that's equal to 5. Take 5 squared, that's equal to 25. So we're going to add 25 into the blank on the left side. Now I can't just arbitrarily add 25 to an equation, that would change it. So I can add something as long as I subtract it on the same side. So next to the 9, I'm going to subtract the same 25. You have to keep your equation balanced at all times and equivalent to the original equation. So adding 25 and subtracting 25, everything is still equivalent. We're going to factor the piece on the left, and of course this is a perfect square trinomial, so this factors as x, pick up the sign from the middle, minus, pick up half of b, which is 5, and it's a perfect square trinomial, so it's x minus 5 squared. Next, 9 minus 25 is negative 16, and that's equal to 0. From here, we can move the 16 over and solve using the square root property. So move the 16 over, it goes over as positive 16. Take the square root of both sides, we get x minus 5 is equal to plus or minus the square root of 16, which is 4. Move the 5 over, so x is equal to 5 plus or minus 4, and then split it up with plus and minus. 5 plus 4 is 9, and 5 minus 4 is 1. So the solution set is 9 and 1. Next, let's look at example 10. Solve the quadratic by using complete the square. We have 2x squared is equal to 7x minus 4. Again, we need to write everything on the left side. So we get 2x squared minus 7x plus 4 equals 0. First, we're going to factor out a 2 from the first two terms only. So that would give me 2 times x squared, and then what number times 2 is equal to negative 7? That's the fraction, negative 7 halves. X plus blank, and the 4, we don't factor the 2 from the 4. We just leave it alone on the outside, and we'll deal with it later. So you only factor the lead coefficient from the x squared term and the x term, not the constant term. Next, we complete the square on this part in the parentheses. And so we'll take 1/2 of 7 halves. So that would be 7/4. Then we take 7/4 and square that, and that would be 49 over 16. So we're going to add and write a 49 over 16 into the first blank. Now notice that that is not exactly what was added to the equation. The 2 from the lead coefficient would distribute to the 49 over 16. So what we have actually added is 2 times 49 over 16. And thus, that is what we need to subtract on the right side. 2 times 49 over 16. So make sure you take into account the lead coefficient whenever you're finishing the complete the square part. Well, the left-hand side, we just follow the same format as before. We have the lead coefficient, we have the variable, we pick up the sign from the b, it's a minus, and we pick up what 1/2 of b was. Some of these look daunting to factor. You don't have to worry about it, just pick up half of b from over here. So it's x minus 7/4 squared. And then next we need to simplify this number. So I'll start by doing 4 minus the 2 on the top simplifies with the 16 on the bottom to make 8. They cancel. And then we need to add 4 minus 49 over 8. And that would be minus 17/8. 0. Next, we need to move the 17 over 8 to the other side. It comes over as a positive. Before we can use the square root property, we have to get rid of the 2 that's a lead coefficient. So I'm going to multiply both the left and the right side by the reciprocal of 2, by 1/2. And that will cancel the 2's on the left, and we'll just multiply the results on the right. So it leaves me with x minus 7/4 squared, and that's equal to 17 over 16 on the right. Now we take the square root property. I'm going to write it over here to save some room. So we have x minus 7/4 is equal to plus or minus the square root of 17 over 16. When you take the square root of a fraction, remember that you can split that up by taking the square root of the numerator and the square root of the denominator. The square root of 17 cannot be simplified, but the square root of 16 is 4. Then I'm going to move the 7/4 to the right side. It comes over as a positive. So we have 7 over 4 plus the square root of 17 over 4. And since they both have the same denominator, we can combine them into one big fraction. 7 plus or minus the square root of 17 over 4. Those are two different answers because of the plus or minus. And finally we have the statement. The solution set is 7 plus or minus the square root of 17 over 4. Let's look at example 11. Solve the quadratic by using complete the square in terms of a, b, and c. And it's the general quadratic ax squared plus bx plus c equals 0. Since it's in terms of a, b, and c, the answer will have a, b, and c in it as well. So we start with the equation. We follow the same steps as usual, just using letters instead of some numbers. We have a lead coefficient of a, so I'm going to factor out a from the first two terms. So we have a times x squared, and then to figure out what comes next, we ask ourselves, what times a gives me b times x. And that would be b over a times x. And you can check that by redistributing. A times b over a is b, and then of course there's the x. We're going to do complete the square, so we set up some blanks. The c is on the outside, and we have a blank for it as well. Now we need to complete the square on the middle part here that we've created. And so we're going to take 1/2 of b over a. That's going to be b over 2a. And we'll take b over 2a and square it. And we'll square the top and get b squared. And then square the bottom and get 4a squared. So we need to add in right here, we're going to write this, b squared over 4a squared. And again, this isn't exactly what we added to the equation, it's what we wrote in there to complete the square. The number b squared over 4a squared is being multiplied by this lead coefficient of a. So to make things balanced, we need to subtract a times b squared over 4a squared. So to finish completing the square, we have a, and then we have our perfect square here. So it's x, pick up the sign from the middle, plus, pick up half of the x coefficient, so that's b over 2a squared, plus c, and then I can do a little bit of simplification. I have a divided by 4a squared, so that's going to be 4a on the bottom. The b squared stays the same. So the rest of this problem is just moving the constant to the other side, dividing by the a, and then using the square root property to get to the x. So I'm going to simplify the constant that's on this right half over here. First part stays the same. I need a common denominator. So the common denominator that I can use here is 4a. So I'm going to do 4a over 4a as the common denominator. And so that gives me plus 4ac, and then the common denominator is 4a. Of course, the b squared over 4a already has the 4a, so it doesn't need anything. Next, I'm going to move the constant term to the right side. So it goes over as a negative. 4ac minus b squared over 4a. Hopefully this is starting to look a little bit familiar, maybe. I'm going to go ahead and move the negative into the numerator of the fraction. I'm going to move this numerator into both of these parts. Basically, you're multiplying by -1 and you're distributing. That would make the b squared term positive, so I'm going to list it first. And the 4ac was positive, so that's going to make that negative. You end up with b squared minus 4ac all over 4a. Next, we need to get rid of the a as the lead coefficient. So we do the same trick as before. We multiply by the reciprocal of the lead coefficient, 1 over a. I can do that because I know that a is not 0, because otherwise it wouldn't be a quadratic. On the left side, that cancels out the a's, and it leaves us with the following. X plus b over 2a squared is equal to b squared minus 4ac over 4a squared. These two a's multiplied together. Now I'm ready to use the square root property. So we get x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 4a squared. Again, when you have a square root of a fraction, you can split that up over the numerator and the denominator. Put the plus or minus on the numerator, and b squared minus 4ac stays inside the square root. On the bottom, however, 4 is a perfect square, and that's a 2. And then a squared is a perfect square, and the square of that is a. And 2 more steps. Let's move the b over 2a to the right side. So we get negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And then, of course, they have the same denominator, and we combine them. So it's negative b plus or minus the square root of b squared minus 4ac over 2a. And of course, that is the quadratic formula. So that's how you derive the quadratic formula. You start with the very general version of a quadratic, ax squared plus bx plus c, and then you just complete the square. You end up with the quadratic formula. Of course, you're responsible for knowing the quadratic formula in this class and how to use the quadratic formula. Let's do some examples of that in example 12. Example 12 says, solve the quadratic by using the quadratic formula. The quadratic this time is x times x minus 3 equals 8. So before I can even solve that using the quadratic formula, I need to write it as a quadratic. So first I'll distribute the x, and then I'll move everything to the left side. So it's x squared minus 3x minus 8 equals 0. Now we're ready to use the quadratic formula. We just need to figure out what all the letters represent. So the a is the coefficient of the x squared term. So a is equal to 1. The b is the coefficient of the x term, and it's negative 3. So don't forget to pick up the sign that's in front of each of these coefficients. C is the constant term. Don't forget its sign either. C is equal to negative 8. So the quadratic formula, of course, is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So x is going to equal negative, and then the b is negative itself. It's negative 3. So we've got to put that in parentheses. Plus or minus the square root of negative 3 squared minus 4 times 1 times negative 8 divided by 2 times 1. This gives me x is equal to 3 plus or minus the square root of 9. Negative 4 times 1 times negative 8 is positive 32. That's over 2. And one last step, x is equal to 3 plus or minus the square root of 41 over 2. 41 is prime, so it can't be simplified. So the solution set is 3 plus or minus the square root of 41 over 2. The discriminant is a very powerful tool used to tell us what type of roots and solutions that we have and how many of these solutions we have. The discriminant comes from the quadratic formula. So if you start with the basic quadratic, generalized quadratic, ax squared plus bx plus c equals 0, then the discriminant is the b squared minus 4ac. That's the formula for the discriminant. And you'll recognize that as the part of the quadratic formula that's under the square root. So this will tell us the following pieces of information. If this discriminant turns out to be positive, then we know that this quadratic will have two real solutions. If the discriminant turns out to be 0, then there is exactly one real solution. And if the discriminant turns out to be negative, then there are two imaginary solutions. So a lot of times you'll be asked to find the number and the types of solutions to a quadratic equation, and you can use the discriminant to solve it without actually knowing what the solutions are. Let's take a look at example 13. Example 13 says, use the discriminant to determine the number and type of solutions to the equation 7x squared minus 3x minus 2 equals 0. This equation might be difficult to solve and find the solutions, but we can know the number and the types of solutions by using only the discriminant. So we know we need A, which is 7, B is negative 3, and C is negative 2. Next, we compute the discriminant, which is B squared minus 4AC. So this would be negative 3 squared minus 4 times 7 times negative 2. That would be 9 plus 56. And that's equal to 65. More importantly, it's positive. So if we have a positive discriminant, that tells us that there are two real solutions. And finally, example 14. For what values of b make the equation 2x squared plus bx plus 50 equals 0 have exactly one solution? So if there is exactly one solution, then we know from our chart that the discriminant is equal to 0. It's the only way we can have one real solution. Well, the discriminant is b squared minus 4ac, so we know that that has to be equal to 0. From the quadratic, we know that the a is equal to 2, and the c is equal to 50. The b is what comes next. So we'll solve for the b. We have b squared minus 4 times a is 2, and then times c is 50. And then we just work this out. So b squared, 4 times 2 times 50 is 400, so it's minus 400, equals 0. Move the 400 to the right side. We get b squared equals 400. Using the square root property, we get b is equal to plus or minus 20. So the two values of b that would make this quadratic have exactly one solution is positive 20 and negative 20.